Okay, here's number 3, and I asked you to do this in terms of x. It's probably set up for in terms of y, so I kind of misread that, but that's okay. We can do it in terms of x because we've got some other ones that are in terms of y, so we'll get a little variety here. So I wrote it like this. I drew a sketch here, and this is x equals y to the third, and this is x equals y squared. But if we're going to do it in terms of x, we have to have it y equals. So if I say x equals y to the third, if I take the cube root of both sides, I get y equals the cube root of x, or x to the 1/3. And the same over here, if x equals y squared, y equals x to the 1/2. And again, this is my top curve, that's my bottom curve. And it doesn't matter because in each case we're going from 0 to 1, either y or x. So in order to find the area, that equals the integral from 0 to 1. And the top curve, which is this one, that'd be x to the 1/3, minus the bottom curve, and that's going to be x to the 1/2. That's going to be dx in terms of x. So again, this is your top curve. That's your bottom curve. Okay. And then all we have to do is take the antiderivative of that, so that's going to be add 1 x to the 4/3 divided by 4/3 or times 3/4, and then minus x to the 3/2 divided by 3/2 or times 2/3. And we're just going to evaluate that from 0 to 1. And the nice thing about this is we'll zero out here when we put 0 in, so we can have 3/4. X to the 1 to the 4/3 is just 1, minus 2/3. And again, 1 to the 3/2 is just 1. And that's going to be minus 0 minus 0. And if we put these in a common denominator of 12ths, this is going to be 9/12 minus 8/12, and that's just 1/12. So that's your area. So that wasn't too bad. Okay, and if we look at number 4, now this is already set up for y, so we're going to do this in terms of y. Okay, and again, this is my right curve. This is my left curve, so we're doing it in terms of y. Now remember, if you're going to draw the little characteristic rectangle, look kind of like that, where the thickness is delta y, and the height is the right function minus the left function. That'll give you the height or the length in this case. So that's what we got. So we've got the integral. And we've got this thing all set up, so it's not too bad. This will be the integral from, and this is going to go out here, so we're going to go from 0 to 1. You can see that on the graph. And then it's going to be the right curve, which is going to be 12 y squared minus 12 y to the third, minus the left curve, which is 2y squared minus 2y. And that's all going to be with respect to y, dy. So that just equals the integral from 0 to 1. And then we can simplify this a little bit. Remove the parentheses, so we get 12y squared minus 12y to the third minus 2y squared plus 2y, all dy. Okay. And then that equals, we can simplify one more time, 0 to 1. We combine our terms and kind of move the into descending power, so we have negative 12 y to the third. And then my 2y's, 12y minus 2y is 10y squared. And then plus 2y, all dy. And I'm ready to take the antiderivatives. So this is going to be negative 12y to the fourth over 4 plus 10y to the third over 3 plus 2y squared over 2. And again, we're just going to evaluate that from 0 to 1. Well, that goes in there 3 times. I guess we can simplify one more time, so that's going to equal 3 negative. Oh, I forgot my negative over here, pardon me. There was a negative there, so that's going to be negative 3y to the 4th. Okay, plus 10 thirds y to the 3rd. And the 2's cancel, so plus y squared. That's going to be evaluated from 0 to 1. So when we put this in, we're going to have y to the 4th is 1, so just negative 3 plus 10 thirds plus 1, and then minus, and this is just going to be 0, 0, 0. Again, this is my f of b minus f of a, fundamental theorem calculus. And this ends up being just, I can think of this as negative 3, and that's going to be plus 3 1/3 plus 1. So that's just going to be 1/3 plus 1, which is 4/3. So there's your answer. Okay? So not too bad. Hope that makes sense. There we go.